Good morning, everyone. In today's session, I will introduce a new user-defined data type in C language, which is union. In a union, single storage location will be shared by one or many heterogeneous data members, that is, different types of the data members. Now, let us see the syntax for defining a union. So, the syntax is given just like this. If you observe this syntax, the union is defined by using the keyword called as an union, followed by the tag name, opening bracket, different member variables, and then closing bracket. Within the brackets, we are providing one or more union variable names. If you observe, this tag name and then this variable list is provided within the square brackets, which does mean that these two are optional ones. Let me explain you some of the keywords here. First one, the union is a keyword which is used to define the union user defined data type, and the tag name is given in the square brackets is used to refer to the union in further reference of the program. In the case of the anonymous unions, this tag name need not to be provided. That means if you don't want to refer this union further in your program, then even though you don't give this tag name, that does work fine. You must keep this tag name in the case if you don't use this union further reference in your program. A union may contain one or more member variables just like this. And one more specialty with this union will facilitate you for the heterogeneous data types. For example, you can use an integer variable, a float variable, a char variable all together in one single union data type. When you declare a variable just here, the memory allocation will happen in the union, and that memory location will be taking the size of the maximum data type size which is among these different member variables. Let us see this example. If you observe here, union is the tag name, and then data is union is the keyword, data is the tag name, and then it contains three of the member variables. One is I, second one is F, third one is an str of 20. And then this is having one single variable which is var. Now, let us try to find out what will happen in the case of the memory location. During the memory location, we are having three different variables. The memory will be occupied, the memory will be considered for the which is the maximum value. Since we are having three different variables, I, F, and then str, it is going to consider whichever the maximum value, that much of the memory location will be allocated for the variable var. And then all the three different variables I, F, and then str, all these three variables will share this common space location. Even though if it is an integer value, the integer value will store here, and then f is a float value, even that f will store in the same location. Even though str is of the character type, all these three will share only one common memory location. and then this is named after the variable name, which is var in our example. Now, in order to access these three member variables, we use the similar kind of the syntax used for the structure, which is nothing but the variable name and then accessor operator, which is called as a dot operator. Now, in order to access the I, then we will write down var dot I. Similarly, in order to access this f, then var dot f, and then in order to access this str, var dot str. This is how the memory will be allocated for all the different types of the variables which were declared in our union. So, I will occupy 4 bytes of the memory in the case of the 64 bit. F will be occupying 4 bytes of the memory, which is of the floating type. str of 20 is a character array which will occupy 20 bytes of the memory. So, here among all these sizes, the first one is of the 4 bytes, second one is of the 4 bytes, third one is of the 20 bytes. Among all these, this 20 is the maximum, hence where will be allocated with the 20 bytes of the memory. Let us now see an implementation of that. In order to declare variable, what is the syntax? Union keyword space the union name, let us say num types, and then inside this num types, let us declare different variables with all the numeric type of the data type variables, which are int a, float b, double c, long d, long double e. This is how we can declare our own user defined variable, our own user defined data type, which is of the num types. And this num types is having 5 member variables a, b, c, d, and then e. A is going to take the size 4 bytes, B is going to take the 4 bytes, C is going to take 8 bytes, D is going to take 8 bytes, and then E is going to take 10 bytes. So, among all this, what will happen when we declare a variable? Let us see. We can declare a variable here as in var. Otherwise, even we can declare inside the main function. So, let us find out what is the size that is allocated. Why I am talking about these sizes? Majorly because if you closely observe, uh, though the declaration, definition, and then access will look similar like the structure, there are certain differences. In order to explain that, I am taking this example. Now, let me print what would be the size of this var. So, in order to print the size of the var, I am going to use printf %d, comma, the special kind of the operator that we are having, size of var. So, let me save this program, compile this. Now you can observe the maximum size of the data, what is a long double, that much of the size will be allocated for this variable var. Let us also print the value, printf %d, comma, size of long double. So that is how the memory will be allocated. Let me erase this too and then check once again what is happening. So both the sizes, among these we are having the maximum size is also 8 bytes, as well as the total memory will be allocated for this union variable is also 8 bytes. Now let us try to access the individual members using the variable. So if you want to access the member variables which are inside this num types, we can access using the access operator, which is called as an dot operator or the accessors. Now, in order to access, we will be using var dot a. We can assign the value just like this, and then we can print and then check what will be the value in order to access that. Printf %d semicolon, comma, var dot a. Now you run this code, we are expecting to get the value 45 here. Now let us access the value, let us initialize the value var dot b equal to some 5.5. Let us print the value, printf %d, comma, var dot b. If you execute this code, you will understand we are going to get %f, right? So small mistake, %f, and then if you print it, we are going to get the value 45 comma 5.5. Let us give some backslash n here, and then here also, and then execute this code. You will get the value 45 and then 5.5 respectively. Now let us try to print what will be the value after assignment. So after assignment of the var dot b, printf backslash n the value after b assignment is %d, comma, var dot a. Now you can understand that before allocating the value for B, the value in A is 45, but after you assign the value to B, now the value in A will be a garbage value, which is a meaningless text. That means this union is having an advantage of saving the memory. When you declare a variable for this num types, then it is going to allocate memory for the maximum size of the data type inside this union members. But the problem is, since all these three variables are sharing the common location, you cannot use them simultaneously in at a time concurrently. So let us check out the significant differences between the structure and then union now. Before going to that, let us also try to read the value in C where dot where dot C equal to some 15.5 printed percentage LF comma C, where dot C. That is how we will access the member variables in the union. Let us execute this code. If you could able to execute this code, you will get this. This is the value 15.5. So that is how you will get the value of the double type. Now let me give you the significant differences between the structure and then unions. Let us try to declare one more structure variable here using the same syntax. I am going to declare, instead of the struct and then num types 1. Now here var1. So the only difference that I made, I declared a union with the three different variables of the three different data types, int, float, double. Similarly, I also declare one more structure with the three different variables, int, float, double. Now let us try to find out what are the differences significantly here. First, coming to the total memory allocation. So if you want to find out what is the memory that is allocated for a union, then we will be using something called as an printf %d comma size of union variable is var, right? So I am going to use a var. Here for the display purpose, I am just writing down the size of union, whereas for the size of the structure, printf \n the size of structure %d comma size of var1. You can identify that this var is of the type union num types, and then var1 is of the type structure num types 1. Now let us try to print out and then see what is the first difference. See, for the union it is taking 8 bytes of the memory, whereas for structure it is taking 16 bytes of the memory. Why it is taking 16 bytes of the memory? Because it is going to allocate memory for all the individual member variables in this structure type. Now you can observe that A is going to occupy 4 bytes of the memory, B is going to occupy 8 bytes of the 4 bytes of the memory, and C is going to occupy the 8 bytes of the memory. In the union case, the maximum size occupied by the union will be the maximum size of the data type among all these, because 4, 4, 8, 8 is the maximum size. So hence where is going to allocate the memory 8 bytes, and then within this 8 bytes only A, B, C values will share their memory location. And then if you consider this var1, it is going to allocate the memory for all the member variables separately, for A, B, and then C. For A it is 4 bytes, for B it is 4 bytes, for C it is 8 bytes, totally 4 plus 4 plus 4, 4 plus 4 plus 8, which is 16 bytes. So that is how it is going to allocate. And then second difference is, you can access var1.a, var1.b, var1.c concurrently without any disturbance, since each of them are taking the different memory locations. So you can simultaneously use var1.a, var1.b, var1.c. Let us find out what will be happening. So I am going to assign var1.a equal to 10, var1.b equal to 25.5, var1.c equal to some 45. Now let us try to print out printf %d, %f, %lf, comma var1 dot a, comma var1 dot b, comma var1 dot c. I think you are pretty familiar with this structure declaration, right? So structure variable will also access the member variables by using the accessor operator, which is called as a dot operator. Since we are having 3 different values, I just separated all these 3 different values using the spaces. So first one, %d, which is of the integer type, then it is going to print the value which is there in first variable after comma. What is the first variable after comma? var1 dot a is the first variable. So that is why 10 will be printed here. Then we will get the space. Then we are going to print the float value, which is 25.5 and then 6 zeros. Then we are going to print the value var1 dot c, which is 45 point, the decimal values. Now let us save this code and then execute. Now you can understand the values that are printed 10, 25.5 and then 45. Since we are allocated the values for this, A is 10 and then B is 25.5, C is 45. Now let us use the similar kind of the assignment for the union variable. If you do that, Control C and then Control V, let us just simply change the values. Instead of the var1, var, here also var, and then var. In order to give the difference, let me the values in the structure are comma. Similarly, the values in the union are So let me give you some backslash n, here also backslash n. Now save this code and then execute. So you can find out from here, you can observe. So among all these three values, we are only able to access in the union one single value, which is a var.c. Why we are able to access only var.c is because there is a common location of the memory for both a, b and then c values. Because we are having three different variables sharing the common location, what is the most recent update in the memory that will reflect for the rest of the values also. So that is the reason we are going to get the value only for var.c, whereas in the case of the structure that is not happened. We are going to comfortably access all the values of a, b and then c concurrently, simultaneously, without any disturbance. And then the first difference is the size occupied by the union will be the maximum size of the among the all the data members of the union. But whereas in the structure case, it is going to allocate the memory as a sum of the individual member variables data type size. So that is the difference between the structure and then union. And then now let us try to understand what is the difference between the union and then array. If you consider an array, so an array is declared like data type space variable name of size, let us say some 55. Now in this case, this var2 will allocate the memory for 55 different values, but all these 55 different values, each of them will be having the size of the integer, which is 4 bytes. The total memory which is occupied by this variable is a multiplication of the data type size into the size of the array. And here all the 55 values should be of the type integer. But whereas in the case of the union, that will not happen. Union will support pooling of heterogeneous data elements. I repeat, heterogeneous data elements, which does mean that all these different values need not to be the same data type. So you can take an integer variable, you can take a float variable, you can take a double variable. Now let us try to find out where we can make use. Since this is having its own advantages and then limitations. The advantage of this union, suppose if we are only using the variables which are of the temporary type, then for all these different variables, you need not to waste the memory. Suppose if you are using a only for a certain time, b only after certain a time, c only after certain a time, then instead of allocating memory for all different variables, we can use the same storage memory location for all these and then create a union and make use of it. I think you understand where we can use it. We can only use the unions when you are having the memory limited resource programming. That means where your memory size, the total memory occupied by the union should be total memory occupied by the program should be minimum. Then in that case you can reduce the total temporary variable data type sizes by assigning them in this union by including them inside this union variable. So in this session we understood what is a union. So union, let me give the summary. A union is a user defined data type where you can have the heterogeneous elements combined together in one single block, and one variable can be used to access all these member variables. Here the tag name is option. Even though you remove this tag name, that doesn't make sense since we are not using this tag name further. Suppose if you execute this code, you are not going to get any difference. But suppose if you want to access here the tag name, then you need to use union space, and then here suppose you want to declare numeric num types space some p1, then in this case definitely we need to have the tag name. Okay. So this is the second thing, and you can declare variable here, and then even though you don't want to declare variable here, you can also declare inside this main function comma where. Otherwise you can also declare here as in global variable union num types space var 3. So likewise also you can declare. The difference between var and then var 3, var can be accessed only inside this main function, but whereas in var 3 can be accessed across all the functions inside this program. So that is the difference. Then we understood how the memory will be allocated for the union. So since we are having different member variables, the maximum data type size will be allocated for the variable that is declared for this union. So var 3 will be allocated the 8 bytes of the memory. Since we are having 448, the maximum is 8. Then we understood how we can access the structure union member variables using the union variable. By using the dot accessor operator, we access this union member variables using. So here var is the union variable, and then a is the member variable of the num types. So we could able to access var dot a equal to 10, like that we can access. Then we understood the difference between union and then structure. In the union, the we majorly discussed the 2 points. One is first we could able to allocate in the case of the memory allocation, union will take the maximum size of the member variables, whereas the structure will allocate for all the member variables contiguously. So and then other one that we also discussed, the difference between union and the structure is you can access all the member variables of the structure simultaneously, but whereas in the case of the union you can only access exclusively one after other. You can take any one of the order, you can start with B, you can start with C, you can otherwise go with a A. So that is how you can access. Then we also find out the difference between array and then union, and then array and then structure. So union is an user defined data type which can provision heterogeneous data type, whereas an array will also array is also provision for multiple values, but in the case all these variables, all these memory locations should be of the same type.